1.3, 1.4, part 1 of the notes. We're going to talk about domain and range. Everybody remember those two words? Yeah. Domain or what values? X values. Good. What's range?
1.
Perfect. Okay, that's part of the battle right there. Some things I want you to remember from domain and range. Write down, please, domain. We read domain from left to right. Whoops. Left to. How about that? Left to right. Same way we read a book. Range. Anybody know how we read range? Up and down. We're going to go from low to high. So we'll say low to high. Bottom to top. But you always read domain left to right. And range is bottom to top. Okay? Domain is our X values. Range is our Y values. So looking at this graph, remember over here is negative infinity. Over here is positive infinity on the x-axis. Down here is negative infinity. Up here is positive infinity on the y-axis. Now, when you're looking at a graph, how do you know that something goes on and on and on and on and on and on and on forever?
Does it have an arrow?
If it has arrows, good. Does this graph have arrows?
No.
No, so I know it has a specific starting and stopping point. Can anybody tell me the difference between the left side of the graph and over there where it stops on the right-hand side?
One dot's open.
One dot's open, one's closed. What does that mean?
It's less than or equal to.
Okay, good. Well, or equal to.
Yeah.
Very good. When you have a dot that is solid, a closed dot, that means it's included. If you have one that's open, the value is not included. Do we remember, anybody, what the notation is for that? If I have a bracket, that includes the point. That's our closed dot. A parenthesis does not include. That's an open dot. And what do we always have on infinities?
An arrow?
But a parenthesis or a bracket?
Oh,
Is there a specific number that you could say infinity stops right here? So it's a parenthesis. It's always going to be open-ended. Mm-hmm. So if you're given a graph that looks like this and you say, okay, what's the domain? I don't have to worry about infinities going on forever and ever and ever because it specifically starts and stops at one point or another. When we talk about domain, remember domain is our x-axis. We read from left to right. So on the x-axis, how wide is our graph? Draw yourself a picture. Draw an arrow to where this graph starts on the x-axis. Where does it start? At -1. And it comes all the way over here to what? +4. Does it include the value x equals -1?
Yes.
Yes. How do you know that?
Closer.
Because the dot's colored in. Does it include the value 4? How do you know? Because it's open. Perfect. Good job. All right, range. How do we read range? Bottom to top. Very important. Low to high. You always read from negative infinity to positive infinity, whether it be left to right or bottom to top. So on the y-axis, what is the lowest point of this graph? At -5. What is the highest point? +4. And what goes on the end of both of those? The square one, the bracket. Good, because it includes it on both sides. Perfect. Questions? All right. The next part of that question says, we'll find f of -1 and f of 2. That's a really interesting way to say, when I look at the x-axis, where x is -1, what is the y value? That's what that's saying. If you say f of -1, what that's saying is go to the x-axis where it's -1. What is the y value of the graph at that point? -5. Yep. When I say f of 2, that means, okay, look on the x-axis where x is 2. What is the y value at that point?
4.
That's it. That's how you answer that question. Does that make sense? We're all right? All right, let's look at these two. First of all, how are these different?
One has arrows, the other one doesn't.
One has arrows, one doesn't. What do the arrows tell me again?
That
That they go on forever and ever and ever and ever and ever. All right, so let's remind ourselves a little bit about domain and range. Again, this is domain is on my x-axis. Negative infinity is on the right. Positive infinity is on the left, right? So think about this. This isn't upside down. This is a parabola. It's just a negative quadratic parabola. But those arrows are telling you that it's continuing on forever and ever. It's forever getting wider. So what values can I use along the x-axis?
infinity.
I can use them all. So I can use from negative infinity to positive infinity. No brackets. We use parentheses because there's no specific place where this starts and stops. Now, as far as the range is concerned, reminder, I'm going to keep saying the same thing 100 times just so you keep hearing me. I want you to hear me in your sleep. Not really, that'd be creepy, but you know what I mean. The range, we read from bottom to top, low to high. So if these arrows are going downwards, I'm starting at what? Starting at negative infinity, agreed. And I go up, 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 up. Is there a point? I don't get any higher. What is it? 1. Perfect. It stops at 1, correct? Does it include it? Yeah. Somebody's going to say to me, well, I don't see a dot colored in. Well, I do. Isn't this a colored in dot since the line is solid? That's considered a colored in dot. All right, always you're thinking, guys, domain left to right, range bottom to top. Let's look at the next one. All right, I have specific starting and stopping points here. So we're going to start on the left-hand side along the x-axis. Where does this graph start? -4, and it goes all the way along to +4. Bracket or parenthesis? All right, good. Brackets on both because it includes. Now think about range. Range is from bottom to top. So look, this is the lowest point right here that this graph goes. What is it? 0. And the highest it goes is?
4.
Perfect. Bracket on both. But remember, when you're looking at domain, you're looking left to right along the x-axis. When we're talking about range, you're looking up and down on the y-axis. Comprende? I know some of you are thinking, man, I did this last year and I just never really got it. Well, we're going to keep practicing it, okay? All right, scooting along. We're going to verbally talk through this a little bit. This will not be on the quiz. But when we talk about domain and range algebraically, right, you're just going to think, what numbers can I use? What numbers am I allowed to put into an equation to get out a certain answer? We're talking negative and positive. So let's look at number 11, right? Number 11. Do I have any domain restrictions? Meaning, are there restrictions on what kind of a number I can plug in to x squared? Can I plug a negative number in there? Yeah. Can I plug 0 in?
Yes.
Yep. Can I plug a positive number? Yep. And I'll still get an answer, right? So what is the domain for number 11? Anything. I can plug in any number from negative infinity to positive infinity and I'll get an answer out. Is my range going to be anything?
No.
Why not?
Because
You're right. You are 100% right, but why not?
Because of the +3?
Not necessarily because of the +3. What happens when you square a negative number?
it becomes positive.
It becomes positive. So can I get any negative answers when I plug? No, I can't get anything that's going to be below 0. So think about that. If I plug in -1, -1 squared is 1. 1 times 2 is, and 2 plus 3 is 5, right? So the smallest number that I could get would be what?
3.
Y. Good for you. Y.
It's the y-intercept.
Okay, it is the y-intercept, but when I plug in 0, what happens when I plug in 0?
0 squared is 0, and 0 times 2 is 0.
Good.
0 plus 3 is 3.
So what are the only answers I can get? From 3 to infinity, 3 and up. So your range here would be, I can get 3 to infinity. Can I get 3? Yes, so it includes it. But it goes on forever. Now, this is just getting you guys to think. That's it. That's all. All right, this is not going to be on the quiz. I just want you to think a little bit. Yes, ma'am. All right, look at the next one. Let's just think for a second. What do we know about square roots?
It can't be negative.
Ooh, they can't be negative. Very good. So let's think about this for a second. Can I plug in just any number I want? Can I plug in any negative number I want? No. What's the smallest number I can plug in?
1.
1.
Why?
Because 0 minus 1 is negative.
Correct. So the smallest number I can plug in is 1. I can get out any kind of number. So like I can go up to whatever is what I mean. I'm sorry. But what happens when I plug in 1?
Makes it 0?
It makes it 0. Is that okay? Can you take the square root of 0?
No.
Yeah. What's square root of 0?
0.
0. So that's all right. So can I include 1?
Yeah.
Yeah. So my domain here, I do have some restrictions here. I can't just plug in anything I want because I can't take the square root of a negative number and get a real number. I can get an answer, but not a real one. So now let's think about what our range would be. The only thing I can plug in is 1 and then anything bigger. So what would my range be? What could my answers possibly be? What's the smallest possible answer I could get? 0. And it could go up to infinity. Very good, guys. Again, we're just thinking. Just thinking. What do y'all know about 15? What does that say? Can't be negative because it's what? Absolute value. Can I plug in a negative number? Yeah, I can plug in any number I want. So my domain, I don't have any restrictions there. I can just plug in whatever I want, negative infinity to positive infinity. But my answer, what's the smallest answer I can get? 0. And up to what? Perfect. Good. See, we're just thinking. I was just getting you guys to think a little bit. Think about what happens when we square a number. Think about what happens when we take the square root. Think about what happens with absolute value. All right? We okay? Does anybody remember the pencil test? The vertical line test?
Yeah.
Yeah? What is it?
I forget.
You just remember talking about it, right? Okay, if you're given a graph and they're asking you, is this a function or not? You don't have the equation, you don't have any points, nothing. You just have a picture. We draw a vertical line. Okay, if I draw a vertical line and it touches my function only, or my graph, it only touches one time, then yes, this is a function. And something is categorized as a function if x values don't repeat. But if you're just given a picture and you're like, oh, I don't know if it's a function or not, just draw a vertical line. When I draw this vertical line here, how many times does it touch that sideways parabola? Twice. So is this a function? No. Nope. What about this one?
Yes.
Yes, this is. And no, this is not. Chances of that being on the quiz are slim to none. All right, we're going to talk about reading graphs and reading intervals of increase, decrease, and constant. Now, what I am about to say in English, in high school English, is what is highlighted here in math book talk, all right? What I'm about to tell you is super duper important. You guys need to write this down and remember, when we talk about intervals of increase, decrease, and constant, we read along the x-axis. And how do we read along the x-axis? From left to right. I cannot impress upon you enough that you are focusing on the x-axis. Because think about it. When you think about decrease and increase, you guys told me what 2 words? Up and down. What axis goes up and down?
Y.
The y. How do we read intervals of increase and decrease? Left to right. Because we're not talking about the increase, the amount that it increased or decreased. We're talking about the interval of time over which it did. There's a difference there. So if we look at this graph here, and I asked you guys your intervals of increase, decrease, you guys would tell me, 90% of the time you tell me, oh, well, it decreases from 4 to 1, then it stays constant at 1, and then it increases from 1 to 4, right? But I would agree with you in your visual terms of the actual up and down. But when we're talking about intervals of increase and decrease, we're talking about the period of time in which it is going up or down. So you always look at just the x-axis. So I tell my kids all the time, whenever I see a question and it says intervals of increase and decrease, I cross off the numbers on the y-axis. I don't even want to look at them. Because now I don't see them. I don't see the 1 and the 4. I don't even see it. The only numbers I see are along the x-axis, which is what matters, okay? When you are notating increase, decrease, and constant, we always use parentheses. The reason we don't use a bracket is because a bracket includes, right? So it is impossible to be increasing and decreasing at the exact same moment. These points where it shifts, where it goes from increase to decrease, it's a turning point. So it doesn't include that point because it cannot happen simultaneously. You can't be slowing down and speeding up at the exact same time. So that's why we use parentheses. So if I was going to ask you guys, and you'll be asked to do this on your quiz, I want intervals of increase, decrease, and constant. If for some reason there is not an interval of decrease, increase, or constant, you have to write none. Don't just leave it blank, because then I think you don't know what you're talking about. And which is definitely not the case, I know. So how do we read a graph? Left to right. So I start over here on the left-hand side. I start right here. And what is my graph doing? I know you guys can read, but what is my graph doing along the blue? It's decreasing, and we look where? At the x-axis. Draw yourself a picture. It's decreasing over the interval of -2 to 0. So you would tell me it's decreasing over the interval of -2 to 0. Parentheses. Then I look back at my graph and I say, all right, well then I have this straight line. What is it doing along the straight line? It's staying constant. It is constant from where to where on the x-axis? 0 to 2. Good. And then I look at my graph and I say, okay, well, what's going on here? It's increasing over what interval on the x-axis? 2 to 4. Very good. I cannot impress upon you enough how important it is to understand and remember that the intervals of increase and decrease, it's not the amount of increase and decrease, it's the interval of time that your graph is going up or down. That's why we look at the x-axis. All right, we're going to practice this a little bit. Let's look at these 3 examples, and then I have one more thing to talk about, and then we'll start on your homework. All right, again, these are hard to see. I understand that. This is from a calculator, from a book, that sort of thing. So we're going to go, I'm going to make a couple little changes here. All right, I'm putting arrows at the end. What does that mean? Goes on forever and ever and ever and ever and ever, right? Where do I look at the intervals of increase and decrease? On the x-axis or the y-axis? So cross off anything that has to do with the y-axis. Now think about over here on the x-axis is negative infinity. Over here is positive infinity. Now if I were going to put my pencil on my function and I follow it, tell me what this is doing the whole time. It's increasing the whole time. So you would tell me, in this case, it has an interval of increase from negative infinity to positive infinity. On a multiple choice test, it might say always increasing or something like that. If there was 3 lines and it said interval of increase and then decrease And then constant. What would you put for the decrease in the constant?
None.
None. No. NA. You can write me a paragraph as to why there's none. You just, but don't leave it blank. Yes, ma'am. Let's put arrows in the end of this one as well. All right, do you see these little tick marks? I know it's hard to see, but this is like 1, 2, and 3 on the x-axis. -1, -2, -3. You guys see them? Now remember, we're talking about intervals of increase and decrease. So we look at what axis? The x, all right? So let's see what we're doing here. Starting over here on this side from infinity, and it's doing what? It's increasing. Now think about this. It's increasing from what infinity over here? Negative infinity to where? Good, Sean. -1. Good. Remember, x, x-axis. Do you see how they gave you that ordered pair? The -1, 2? You know what I would do? Cross off the y value. It cannot do anything but confuse you. Because it makes sense to think, well, how high did it go on the increase? That's not what we're looking at. We're looking at the time that elapsed that it happened. Yes, sir. Just stretching?
Yeah.
Okay. All right, so now I look, and I'm here, and I go where? I'm decreasing. So this is now an interval of decrease. From where on the x-axis to where on the x-axis? Good, guys. -1 to 1. And then what's happening again? It's increasing. Now, the way that you write this, it doesn't matter to me. If you want to write it next here, I say, oh, it's increasing again, that's fine. If you want to list it underneath as an additional increase, that's fine as well. But from where to where is this increasing? 1 to positive infinity. All right, Paloma just asked, well, what about if we have a constant? All right, well, let's look at this. Let's pretend like there's dots here. We're just going to draw them. So this is going to be 1, 2, 3, and this is 4 over there. So this is -1. I'm going to go like that because you're not going to get me. Just look at your graph. From the left-hand side to the right-hand side, what's it doing? It's increasing, then constant, then there you guys go. So we're going to increase. From where to where on the x-axis are we increasing? -2 to 0. Good. From -2 to 0. Draw arrows if you have to. Who cares? Then from awesome. Then from good job, guys. Great job. Yes, sir.
If it went back up, would you make another, like, would you say
Yep,
increasing again?
you could.
Or would you add it to the?
It doesn't matter, whichever you want to do. The question was, if it went back up, say there was another interval of increase or constant or decrease, whatever, you could either put it here, like and, or underneath, you just want to make another increase, decrease, whatever. Does not matter to me. Questions? Yes, sir.
So the example we just did, it's not infinity or negative infinity because it's stopping with the point.
Correct,
right?
because there's specific starting and stopping points. Yep, good question. All right, the next thing I want to talk about is super duper easy, and then we'll start on some homework problems. All right, what does it mean to have a minimum or a maximum value? Minimum's the lowest, maximum's the highest, right? A lot of times when we had parabolas, we'd have something like this, and you guys would tell me this is the what?
The minimum.
Minimum. Then I had a parabola like this, and you told me this is the maximum, right? Minimum is the bottom, max is the top. You guys always have a maximum amount of money you're allowed to spend, or a minimum amount of money you want to spend, right? You have a top or a bottom. Well, when we get into some sort of calculus, when we get into some calculus stuff, you're going to have these graphs that look like this. They got a lot of peaks and valleys. There's bumps in them, right? So there's not a specific, this is the highest that the graph goes. There's not a specific, this is the lowest that the graph goes. So we will talk about relative maximum and minimum. All that is the peaks are the relative maxes, and the valleys or the bumps are the relative what? minimums. That's it. So if you're given a graph, what would this point be? A relative minima. What would this point be? Brilliant. What about this point?
Minimum.
Relative min. What is this? Relative max. Okay, that's it. Tomorrow, we're going to talk about piecewise stuff, all right? Tomorrow, I'm going to upload this in just a second, but I want to work through some homework problems with you and then let you guys have some time to work on it together.